Hey, what's up guys? Welcome back to another video in the Kotlin series. In this video, I'm going to teach you about null safety. Welcome back everybody. So I'm going to teach you guys about null safety, which is handling null values in Kotlin without causing null pointer exceptions. So what is null? A null value in Kotlin is a type of value that simply means the absence of value. It means nothing. Up to this point, we've never really worked with null values, but if we have something like a string variable, you can set that string variable to be empty, meaning it's just an empty string. Or if you have a number, it could be 0. In those cases, there is still a value, but if you have a variable and the value is null, this means there is no value. So null equals no value. Now the cool thing about Kotlin, if you've ever worked with a language like Java, for example, or any other major programming language, you're going to be pretty familiar with null and null exceptions. This is something that you always want to avoid. So if you have a variable that has the value of null, and you try calling a method on that variable, then you'll get a null exception, and it could crash your program basically. The cool thing about Kotlin, however, is that it has a bunch of mechanisms that give you null safety, meaning that you can much more easily avoid null pointer exceptions. So let me give an example. So if I do var name, and name is a string, and we give it the value of John. If for some reason I want to make this string variable have the value of null, meaning that we don't have a name anymore, normally I would just do something like name is equal to null. But in Kotlin, you cannot do this. And this is the first aspect of null safety in Kotlin. If you don't declare a variable as a nullable type, then you can never set the value of that variable to null. And that obviously creates some null safety because since that variable can never be null, you can never get a null exception. So it says null cannot be a value of a non-null type string. So that begs the question, how can you make a variable nullable, meaning that you can set the value to null? All you have to do is go to the type and do question mark. What this immediately does is it tells you whenever you declare this variable here, name, you're setting it to have a data type of string, but it can also be nullable, meaning that it's either a string value or it's null, meaning nothing. That's why this is now legal. You can do this. If we didn't have this here, the program would not even compile. You would get a compilation error because that's not valid Kotlin code. But since we add it there, this is now a nullable variable. It's a nullable string variable type, so now we could do this. So if we want to see what that looks like, we can do sout name, and let's just take a look at what that looks like. And there we go, get null. And again, what is null? Null is the absence of a value. So that would be different. Instead of doing null, if we just do an empty string, or if this was like an integer variable, like we do int. If we have a nullable int and we do 0, let's say it's 12 initially, or even 0 initially, this is all valid, but that's not the same thing as null. There is still a value, and you could print out this value if you want to. But if for some reason you want to indicate that there is no value, or you want to have a placeholder for this variable, you can do null. So now that indicates that this variable is existing, it exists in your computer's memory, but it doesn't hold anything, it has no value inside of it. Let's talk about null exceptions again. If I want to, I could do name.length, and this will just print out, 4, because John has 4 letters in it. And this would be valid in another programming language. This would compile and you could run this and you'd get 4 on the console. But if in between these 2 lines of code I did name is equal to null, if I compiled and ran this code in another language like Java for example, this would, at this point in the code when it does line 10, this would generate a null pointer exception because what you're trying to do is access a property or a method on a variable that has the value of null. That is something that you can't do. That's invalid because as it says here, length returns the length of this character sequence. If there is no character sequence, if the value of this is null, that doesn't make any sense. So you're trying to run code on something that doesn't exist or it's null. And that's how you get null exceptions in other languages. So the cool thing about Kotlin, as you can see here, is already warning us that we're doing something incorrectly. It's smart enough to know that because we have a nullable type here, we cannot just directly call name.length anymore because it could be null. And it is null in fact, but even if I have this not there anymore, this would give us a compilation error because this is invalid. And this plays more into what I talked about before, which is null safety. Kotlin has different ways for you to safely access nullable types so that you can avoid null exceptions. And to be clear, if I just remove this question mark here to make it a non-nullable type, just a regular string type, this is now perfectly valid because we are guaranteed by the Kotlin language that this variable here has a value of string and it can never be null. Therefore, we can call .length without worrying about null pointer exceptions. Alright, so now that we know what null is and how we can make a variable nullable, the question is now, how can we safely access and work with nullable variables? The first thing that we could do is just use a simple condition and if statement. So if we have a variable grandpa, and grandpa is a nullable string type, and has the initial value of Billy, we could do something like if grandpa is not equal to null. If grandpa is not equal to null, then we know that we can safely at this point call methods on it and call some other properties on it. So first we could do something like grandpa is grandpa. So let's just print grandpa out just to prove that it's not null. But then we could also safely call grandpa has grandpa dot length characters. Now, as we saw above, when we make this string here nullable, this is no longer valid, right? Because you can't call dot length on something that could be null. But down here, since we are first checking to see if grandpa is not null, we're verifying that it's not null, we can call this code now without any compilation issues. This would be a valid program here. And then you could have an else if you want to. You could say else, if grandpa is null, then we could say something like grandpa is null, we can't do anything with him. So if we go and run this code now, let's take a look at what we get. There we go. So we get 4. Grandpa is Billy. So grandpa is Billy. That's the name of that's the value in the nullable string here. And then grandpa has 5 characters because we're doing grandpa.length, which is 5. Makes sense, right? Another example here. So Val has swag, and we could say it's a nullable boolean. That's going to be equal to null. And then we could say if has swag is not equal to null. At this point, if it's not equal to null, we know that this variable has 2 options, true or false, because a boolean is true or false, but when it's a nullable boolean, it's true, false, or null. But inside of here, it's only true or false because we've checked it. So we could do if has swag, and we could say you have swag. Otherwise, this means that it's false. You have no swag, homie. Then down here, if it didn't meet this condition, then we're going to reach this point, right? Meaning that has swag definitely is null. So if has swag is null, then we'll just say another message. We aren't really sure if you have swag or not. Which kind of makes sense, right? Because it's null, we don't know if it's true or false because it has no values, the absence of a value. The next thing that you could do is the safe call operator, which is question mark dot. Now if we just go ahead and cut this example that we have up here, and we move it down here. So we're making a new variable name. Let's make it a nullable string. Now, as we learned before, we cannot call this code here because you can't call dot length on something that could be null. So in this situation, you could either use an if statement to first make sure that it's not null and then call dot length, or you can use the safe call operator. So you could add a question mark in front of the dot. So now as you can see, the error went away, so now it's a valid program. But what this will do is make it so that if the value of this variable name here is not null, then it's just going to do john.length and it'll give you the value of 5 like normal. But if name is null, then the entire thing will be returned back as null. So you just print out null to the console instead of the number 5, for example. So that's how the safe call operator works. If the thing that you're putting the question mark on is null itself, then everything after that, all the calls after that, like dot length or anything that you add onto that, will also be null. That way you're not calling a method on something or a property on something that is null and getting no exception. So this is perfectly valid code now. So let's go and run it and let's see what we get. We should just get 5. Oh, I'm at 4. I can't count. Okay. There we go. But if we do make this name is equal to null, now this is perfectly valid. So if we run this now, we should get null. There we go, we get null instead of like an exception or something like that. And in this example, we're just doing it on one single value. So we're doing name question mark dot length, but you can actually chain these together as many times as you want. So if you have a variable Bob and Bob is nullable, we could do Bob question mark dot, and we want to access the department within Bob, we can get Bob's department. But also Bob's department, he may not even be in a department, so that's nullable as well. So we could do question mark dot. And then if he does have a department, that department may or may not have a head. So we can do head question mark. And then finally, if there is a head of the department for Bob, we can also get their name. So what this code here would do is if Bob is in a department and that department has a head, it's going to return their name. But if this is null, then the entire thing is null. If this is not null, but this is null, the entire thing is null. If this is not null, this is not null, but this is null, the entire thing is null, just because we're using the safe call operator. So again, the safe call operator works by making it so that if the thing that you're calling the operator on is null, then everything after that will be null automatically. And with this mechanism, we therefore have a safe way of working with nullable types in Kotlin. The alternative to the above would be this. So we would have to first check to see if Bob is not equal to null. If it's not, then we can get the department, then we can check the department, then we can get the head. If the head's not null, then we can get the name. All of this can be replaced with this, way more concise. Pretty cool, right? Now we learned about how to make our variables nullable just by adding the question mark. You can also do it with lists as well. So we could do val menu list. So inside of this, we could do something like string question mark. So this would now be a list of nullable strings. And we could do equals list of, and we could do pizza, we could do null, we could do null again. We could add some barbecue to that. We could add some pasta, and then we could add another null. And it may seem silly to add a bunch of nulls in this list that we have here, but if we just think about a real program, maybe these are items that we don't know yet. Like these are just placeholders. Like let's say it's not lunchtime yet. We don't know what item is going to be on the menu, but later on this will be filled in by an actual item. So we may want to have a program that can actually print out all of the items currently on the menu to someone who comes to the restaurant, but we want to avoid printing out all the null values. So what we could do is do for item in menu, and then we could say if item is not equal to null, then we're just going to print out menu item. And that makes sense, right? We're just looping through every single item in the menu. And since we know every single item is a nullable string, we're checking to see if each string is not null. If it's not null, then we can print it out. Otherwise, we're not going to do anything. Therefore, we're only going to get printed out pizza, barbecue, and pasta. Everything else will be ignored. There we go. Pizza, barbecue, pasta. Another thing that you could do that makes this a little more concise is use lit. So if I just get rid of this and I do item .lit and I just tab to autocomplete that, what this will do is only run the code inside of this block here if this is not null. So I could do print menu item and then it. So this will do the same exact thing, but in a different way. It's a little bit more concise. You just have to get used to this weird syntax. So again, this will go through every single item in the list. It'll check each item to see if it's not null. If it's not null, it'll run every single thing in the code block. The next thing I'm going to teach you guys about is the Elvis operator. Elvis operator. And what this will do is give a default value if a variable is null. So if we have a variable, test name is a nullable string with the value of George, we could say if test name is not equal to null, then we could go ahead and print out my favorite person is test name. So that's if it's not null. If it is null, in the else, we could say my favorite person is Henry. So basically the whole goal here is that we're trying to print out who my favorite person is, but this variable here has a nullable string, so it could be null. So we're checking to see if it's not null. If it's not null, we'll just print out the value in the variable. Otherwise, we're going to give it a default name, which is Henry. In Kotlin, there's actually a more concise way to do this, which is the Elvis operator. So instead of doing all of this, we could take all of this, cut it with Control X, replace all of this here. And now here, when we call test name, if we were to run this now, it would print out George, right? That makes sense. But if we made it null for some reason, and we try running this, we're going to get null. So we lost our default value. So to add a default value, we can do question mark, colon, and then just do Henry, which is our default value. So now if I run this again, we're going to get, instead of null, we're going to get Henry. There we go, we get Henry. And then if I change this to Bob, we're going to get Bob instead of the default value. Which makes sense, right? Because the way that this Elvis operator works is, if the thing on the left side is null, and only if the thing on the left side is null, it will use the default value. Otherwise, it'll just give you the actual non-null value that is returned by this. And this can be anything. It can be an expression. It can be a variable, as we have here. So for example, if I took this and this was inside of here, that would be perfectly valid. As long as it returns null or not null, it doesn't matter. Let me just give you another example. So if I do val name length is equal to test name question mark dot length. What this will do is give me the length of the test name if it's not null. If it is null, it'll just give me null because we're using the safe call operator. But if we want to have a default value for if this is null, then we could use the Elvis operator by doing question mark, colon, and then we could say -1. So now the way that this will work is, if test name is a valid non-null value, it'll print out the length of it. If this is null and a value is to null, however, this will be -1. So we could print out length is name length, like that. And we should get 3. Yeah, we get 3. But if we set it to null, we should get -1. And yes, we do. There we go. We get -1. So this line of code here is equivalent to this. If we did not have the Elvis operator, we would have to do if test name is not equal to null, then print out the test name.length, else -1. So that's just another example of how Kotlin makes it easier to work with null values in Kotlin. Okay, so I know this is a long video and I'm giving a lot of information that is probably a little hard to remember, but again, just as a reminder, all the source code will be in the description below, so you can come back to it and reference it at any point with comments and all that fun stuff. The last thing I want to show you guys is the not-null assertion operator, which is exclamation point, exclamation point. So what this will do is force a null value to be non-null. So if I have a variable nullable name, and that's a nullable string of John. Now, if I want to get the length of John, I can do length is equal to, And if I did nullable name.length, we know that's invalid because you can't call this directly on a nullable value. You would have to first add a question mark for the safe call operator so that if this is null, the entire thing is null. But let's say that you don't want length to be nullable. You want to force length to be an integer, an actual valid integer, which is the length of the nullable name. And let's say that you also know that the nullable name is not null. You know for a fact that it's not going to be null. What you can do is override this behavior and do exclamation point, because you are now asserting that this is not going to be null. Even though it is a nullable type, you are forcing it to be recognized as not nullable, so you can therefore call .length. And this is valid, so if we print this out, we get no exceptions or nothing. Pretty cool. So we can also print it out, so we can say length. So if we run this now, this is perfectly valid. We get 4. Makes sense, right? Something that you have to be careful though is that because you are asserting that it's not null, you're sort of overriding that default behavior. This better not be null, or you're going to get a null exception. And this is the whole thing that you're trying to avoid in the first place with all these tools that we're learning about here. So you're going to find yourself in certain situations where you might want to use this operator, but you want to make sure that you use it in a situation where you're pretty sure that the thing that you're using it on will not actually have a null value. Because if it does, you're going to get a null exception and the program could crash. So if I even try doing nullable name is equal to null, this is no longer compilable. It's invalid code because number one, your IDE is smart enough to recognize that this is invalid, but 2, this is only to protect against runtime nulls. So if you're going to assign this as null and then try accessing it using the not null assertion operator, this is invalid. This is for situations where during the runtime of your program, when your program is running, you have a variable and it is a nullable variable, but the value is going to be set during the running of your program, not explicitly by you as I just did. And you want to basically assert that it's not null, even though it could be. So I know that's probably going to be a little confusing, but in the future we'll actually get some real world examples of how we can actually use this in a useful way, okay? And that's pretty much all I want to show you guys for all the different things that you can do. But I want to answer one question, just make sure that it's answered for anybody who might still be wondering why. Why would we want a variable to be null in the first place? Why have nullable variables? Number one, it's useful for when you have a variable but you want to represent the absence of a value. It's useful for variables where you want to have a variable because you're going to be storing something, but you don't know what the value of that variable is going to be yet. Or maybe the variable had a value at some point, but you want to unset it so you can represent the absence of a value in a variable with null. And again, this is just one of those things that, like I said before, it'll make more sense as we code more and more and we learn about more stuff. So that's why we have null and why it's useful. But Kotlin makes it very easy to work with null values, in my opinion, compared to a lot of programming languages that are very popular like Java. It's a much more pleasant experience, is what I'm trying to say. So just as a recap here, what did we learn about? We learned about how to make nullable variables. How can we make a variable with a nullable type, meaning that, for example, for this first one here, this is a grandpa variable. It has a string, but it could also be null. We're adding a question mark, so it's a nullable string. Us adding this question mark here tells the variable that it can either be a string or null. After we learned how to declare nullable variables, we learned how to work with nullable variables using if statements and basic conditions. And then we also learned about the safe call operator, so that you can safely call methods and properties on nullable values without getting null exceptions. We also learned about let, which is a way to run a chunk of code only if the thing on the left side is not null. We also learned about the Elvis operator, which is a way to give a default value if a variable is null. So if we have a name, for example, and it's a nullable string, we can say my favorite person is that name if it's not null. If it is null, we can give it a default value so it'll print out Henry. And then finally, the last thing that we learned about is the not-null assertion operator, which is exclamation point, which is a way of asserting that a variable is not going to have a null value, but if it does, you could get a null exception. You're willing to accept that risk. And that's it. Hopefully you found this video interesting. And yeah, thanks for watching, everybody. Peace. So that's it for this video, everybody. I really hope you learned something new. If you liked the video, please hit the like button, and if you want to see more, hit that subscribe button. Make sure to also check the description below for important links to code and other resources, but also really important, join our Discord. We have a big community of over 5,000 programmers, and it's a place where you can find new friends or get help on any code that you're stuck on. If you want to support what I do on this channel, please consider hitting the join button below, and this will allow you to support my channel for as low as $1 a month, but there are different tiers to choose from if you want to. For anyone that becomes a member on my channel, you get a special rank on my Discord server, early access to new videos, and you can just see yourself on the screen right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. Thank you so much. And that's it. Peace.